Hey, this is a recording, a video that'll show you two things. Number one, it'll remind you how to do a screen or a scatter plot. It'll also introduce you to how to measure correlation. Yesterday in class, we looked at two situations. We looked at your bank account as the month goes on, and we saw a strong correlation between the day of the month, how late in the month it is, and your bank account. In fact, it was a strong negative correlation. We saw the dots on the graph make a pretty good line. On the other hand, we looked at um, engine power compared to the amount of CO2 in a car's exhaust, and we saw a very weak correlation. We didn't see any pattern at all between those two variables. So we started talking about correlation, and today we're going to look at how to measure that. So our first example here is a situation with length. We have on the left here is the amount of feet long something is, and on the right it's how many inches long something is. We all know that there are 12 inches in a foot. But let's go through the exercise of making a graph for this. So I'm going to do that by highlighting and going to insert. I could go to recommended charts. I don't really like those. So this dot here is a scatter plot. You can see it says XY scatter, and make that choice there. Let's make this a little bit bigger. And we'll throw in a title here, inches versus feet. We'll do an axis title here. That horizontal axis is the number of feet, and the vertical axis is the number of inches. And what you'll notice is that these dots make a perfect line. That may not be surprising because every foot is made up of the same number of inches. There are 12 inches in every foot. So every time we go over a foot, we go up 12 inches. Over a foot, up 12 inches, over a foot, up 12 inches. This is a perfect correlation. There is no mystery involved here at all. We can easily predict how many inches something is going to be if we know how many feet it is, because we're just going to multiply by 12. So that is a lockstep correlation, and we see it as a positive correlation because it goes up. And I'm going to show you how to measure correlation. It is a formula in Excel. It is CORREL. And this is a little bit different here. We have to enter two different arrays separated by a comma. So the first array is the first column, which is feet. You can see blocks A2 and A11 there. I'm going to throw in a comma to separate it from the second array, which is going to be the inches column. You can see cells B2 to B11 right there. I'm going to hit return, and the value it gives me is 1. That 1 signifies a perfect positive correlation. We call that we call this number, whatever it is, the correlation coefficient. And its abbreviation is R, lowercase r. So we would say that in this situation, R is 1, and that 1 represents a perfect positive correlation. Now I need to contrast this situation with other situations so you can learn a little bit more about correlation coefficient. That correlation coefficient is designed to be a number that tells us how related feet and inches are, or whatever our two variables are. So let's look at another situation. Let's go back to yesterday's CO2 and engine power situation. This is our graph, and we are reminded that that graph had no correlation at all. We can kind of see this here. It looks like somebody sneezed on the screen. It just looks like a bunch of random dots and no pattern at all. Well, let's find out what the correlation coefficient is for this set of data. I'm going to hit equals correlated. I'm going to do my first array, throw in a comma, do my second array, close off the parentheses. Okay, so here the R we get, I'm just going to throw in R equals so it looks nice. Here the R we get is negative 0.149. Now, a couple of things. A couple of things about this. One is that negative line tells us that this correlation, that negative sign there tells us that this correlation is more negative than it is positive, meaning that if we could put a line that approximated these points, it would be downward sloping. I guess because we've got a lot of points down here and some points up there, that kind of means it's downward sloping, but there's nowhere near a line. It's nothing that looks like a line, and that's why our R value, our correlation coefficient, it's negative, but it's relatively close to 0. It's at 0.149, which is actually pretty close to 0. It's certainly a lot closer to 0 than it is to negative 1. So the fact that R is close to 0 in this situation tells us that there is really very little correlation between these two variables. Now, let me give you a third situation. This is back to the bank account scenario that we did yesterday. I imagine that you would predict a strong correlation because this is looking like a line. It's not a perfect line like the feet and inches were, but it is very much getting darn close to a line. You got this one outlier up there. That'll hurt things a little bit. But it also slopes downward. So let's see what happens here. I'm going to go into this block here, zoom in a little bit here. I'm going to go to that block there, and I'm going to enter equal, whoops, I'm going to spell it right, correlation, and I got to go back up here. That's my first array. I'm going to make a comma. Go back up here to my second array. And I'm going to hit return. Look at that. I get negative, as we predicted, negative 0.984. That is a very strong negative correlation because it's very close to negative 1. Excuse me. So what we're learning about correlation coefficient is that a perfect positive correlation is 1. A perfect negative correlation is negative 1. And no correlation at all is 0. So this is what we've learned so far. Correlation can be positive, negative, or 0, and it can be strong, weak, or none. The correlation coefficient, which is abbreviated R, it's always a number between negative 1 and 1. A positive R is a positive correlation, which means as one of our variables increases, the other also increases. A negative R, a negative correlation coefficient, means a negative correlation, which means as one variable goes up, the other goes down, like in our bank account. So if R is close to 1, it's a strong positive correlation, like this side of my little number line here. If R is close to negative 1, it is a strong negative correlation. And if R is close to 0, there is a weak correlation or no correlation at all. So there's a continuum. This side here is negative. As we get closer and closer to 0, it signifies a weak correlation. Same thing on the positive side. These numbers 0.1, 0.2, and here are going to be a weak correlation. You probably won't even think that there's one at all. But as you get closer and closer to 1, those points are going to form more and more of a line. So what I'd like you to do now is get a sheet from Ms. Lesher, and it's going to be a pictures of 6 different graphs, and you're going to match the R value that makes sense for each graph to that graph. And then when you're done with that, I'm going to ask you to watch this next video, and so we can go over that together. All right? Thanks for watching.